In this session, I will be discussing about leveraging the benefits of fly ash in mega infrastructure projects. We all know about the technical benefits of fly ash, so I'm not going to take much time on this, but just to brief, when we are using fly ash, it helps in significantly reducing the heat of hydration. So it is very helpful for mass concrete construction in controlling the thermal gradients, the thermal cracks, as well as preventing delayed adringite formation. Because it is having spherical shape, it helps in improving the workability, the cohesiveness, which improves in the long distance pumping and high rise pumping. And since fly ash gets into a pozzolanic reaction with calcium hydroxide, it enhances the ultimate strength and durability of the concrete over a long period of time. Now we all know about the benefits of fly ash. Let us try to understand since how long we have been successfully using fly ash as a part of our infrastructure projects. The Bandra-Worli Sea Link project, one of the most iconic projects in India, designed for a 100 years of service life, exposed to sea conditions, so very severe exposure conditions. In this project, we have used on an average about 30% fly ash replacement in all the concrete elements. And again, since we were producing concrete on the land and taking the concrete all the way into the sea, we had designed this concrete for an 8-hour retention. The fly ash helped us in improving the long-term strength, durability, as well as allowing us to have a long retention of 8 hours. The next important legacy project is the Rajasthan Atomic Power Plant. It has very massive rafts. We are working in a severe hot weather condition and we require a crack-free structure for the nuclear reactor where we need the radiation shielding to happen. Now in this project, 5, 6 as well as 7, 8, RAPP 5, 6 and 7, 8, we have used fly ash ranging from 25% to up to 50% in various elements. Now, I don't think we require a bigger certificate for fly ash than we are able to use it successfully in a nuclear reactor. Let us look at some of the recently completed projects. This is the Nagpur Mumbai Samruddhi Expressway. We have used fly ash in all the elements, but I have just mentioned the PQC here, where we have used about 23% fly ash. This is the most iconic metro tunnel under the river Hooghly in Kolkata Metro, where we have used about 23% fly ash for the M50 grade precast elements. There was no need to add that 5 kgs of microsilica. However, on the insistence of the client, we did that. Again, this is another iconic project, the first of its kind in India, a double-decker bridge where on the top you have the metro and on the first level you have the NHAI flyover. Again, here we have used fly ash in all the elements in the range of about 20 to 25%. This is the most iconic bridge project in India, which was very recently inaugurated on 1st of May, the Missing Link project, where we have the pylon of 184-meter height, where we have used about 28% fly ash, and the M70 deck, which is 110 meters from the ground, where we have used about 22% fly ash, and still we are able to achieve an early strength of 40 MPa in 3 days. One of the most difficult projects to execute, having a design life again of 100 years, all infrastructure projects have that, and the durability requirements are very stringent. Current projects which we are working on, this is the Maldives bridge project, where we are connecting the 4 major islands of Maldives, that is Malé, Willingly, Gulifalu and Tilafushi, by a series of bridges and roads. The depth of the sea here is almost in the range of 45 to 50 meters. Some of the photographs of the project, again here we have an M60 grade pile, 2.5 meter diameter and 120 meters deep. Here we have used about 27% fly ash, and the 40 kgs that you see here is not microsilica, it is ultrafine fly ash. Similarly, for M55, we have used about 140 kgs of fly ash, that is 26%. One of the most difficult projects, 120-meter long trimmy pile to be done. It requires concrete to be extremely cohesive and flowable to have a workability of more than 10 hours so that we are able to easily complete the pile without any problems. And fly ash has definitely helped in doing the mix design correctly. This is currently what we are doing is the high-speed rail, again M70 grade precast elements, 21% fly ash plus 30 kgs that we see here is ultra-fine fly ash. So it is not just the fly ash which is important material. The ultra-fine fly ash is also able to replace microsilica in a very good manner. And finally, the very recently we have started this project in sea connecting two parts of Mumbai, where we are using 22% fly ash. Having seen a wide range of projects where fly ash has been successfully used, we get a confidence that it is a material which can be used across all kinds of infrastructure projects without any issue. But at this point, it is very important that we ask two important questions. First is, we know that fly ash is the future for good concrete, and we should use it from the technical as well as sustainable point of view. But are all projects in infrastructure allowing us to use fly ash, or we still have some old legacy specifications which do not allow us to use fly ash? So that is one of the constraints we need to discuss. And second very important point is, we know fly ash is a great material, but is any fly ash coming to the project good enough to give us a durable concrete? So we'll first talk about the constraints and then we'll talk about the pitfalls. The biggest constraint is we still have many high value infrastructure projects where we are prohibited to use fly ash. Further, there are a few projects where we are allowed to use Portland pozzolana cement, but we are not allowed to blend fly ash in the batching plant. Now, this restricts us from creating the most optimum mix for the project. It could be TBM segments or mass concrete rafts where I could use more fly ash and do a better mix design. And finally, we have the fantasy of approving a mix design or qualifying a mix design at 28 days. We need to understand that when we are using fly ash or any supplementary cementitious material for that matter, the hydration process could be a little slow, and maybe qualifying the mix at 56 or 90 days would be a good idea, especially for mass concrete elements. But that still doesn't happen. Now we'll talk about the pitfalls and then I will conclude the session. One of the biggest pitfall that the contractor has is the cost saving trap. The contractor many times looks at fly ash as a cheap substitute of cement and adds fly ash more than what the optimum design would really be. And in that case leads to serious failures. We must understand that fly ash is a performance mineral. It is not a cost saving byproduct. If we get into that, it could lead to serious problems. And the second pitfall that the contractor needs to understand is that not all fly ashes coming from the same power plant will have the same quality. We look at initially the physical and the chemical properties, but for every batch, we must look at the fineness and the loss on ignition before we unload it into our silos. For high strength concrete, it is recommended that the maximum 45 micron retain should be less than 20%, though code allows up to 34%. Now, with my final remarks, I would like to conclude by saying that there has been a paradigm shift in how we look at fly ash maybe a decade or two back and how we look at it today. Today, it is no longer a waste, it is a strategic resource which we must judiciously use. It is a requirement for the quality of our infrastructure projects, be it for controlling the heat of hydration or be it for long distance or high rise pumping. And finally, the most important point is that by using fly ash in concrete, we significantly reduce the carbon footprint of our concrete and we move closer to India's goal of becoming net zero by 2070. With this, I conclude my presentation. Thank you very much.